Hey everybody, we're back, and since the first video on optimization took a little longer, I'm making a second video to finish up example 1. So here we are. What we had decided on the first video was that the optimal dimension to cut the squares was x equals 1.585 inches. What I want to do now is actually use a chart, a first derivative chart, to prove that indeed that's going to create our maximum volume. So again, prior lessons tell us that the chart will get set up like this. We're going to analyze V prime versus V to make our number line. And on that number line, we're going to put our critical point, 1.585. What I want to do is choose an x value to the left that makes sense and plug it into the first derivative of V. Now, be careful here. In our other examples that weren't real world, we could choose anything to the left of 1.585. I got to be careful here. I don't want to choose negative values because negative side lengths of squares don't make sense. I also don't want to choose 0 because if I choose 0, then I haven't cut anything off the corners. So I'm going to choose something like 1. If I cut 1-inch squares, what's the volume doing? So go back to V prime. Let me find that. Okay, V prime is right here. If I plug 1 in for these values, then I would have 12 times 1 squared minus 78 times 1 plus 93.5. And that's giving me a positive slope of my tangent line. So this is going to be plus, and that's going to tell me that my volume is on the increase, it's on the rise, as the side lengths of my squares that I cut approach 1.585. Now I'll choose a value to the right. I might choose something like 2, which is actually what I cut for my box. If I plug 2 into the first derivative, then I'll have 12 times 2 squared minus 78 times 2 plus 93.5, and that gives me a negative value. So I'll put my negative here, and that implies that the volume is decreasing at that point. So I have indeed proven that I have a maximum here because the sign of my derivative goes from positive to negative. So I'm going to make that statement. I'm going to add on here. So I'm going to say the maximum volume is, for now I'm going to leave it blank because I really don't know the maximum volume yet. I know I have a maximum volume, but I don't know what it is yet. So the maximum volume is blank since the sign of V prime changes from positive to negative when x equals 1.585 inches. Now, let's find that maximum volume. Okay, all I need to do there is plug 1.585 back into my volume equation. So if you look back, your volume equation from the very beginning, this isn't V prime, this is just V, was 4x to the third minus 39x squared plus 93.5x. So if I plug 1.585 in for all these x's, I'll have my blank here. One thing I want you to be careful of, in optimization, you don't want to round answers until the very last step. So this is a rounded answer, but when I plug it back in, I want to use what it was unrounded. So I'm actually going to back it up to earlier when I found 1.585. I found that by taking, I'm going to redo this, 78 minus the square root of 1,596 divided by 24. Okay, so there's that 1.585 figure unrounded. What I'm going to do is I'm going to hit the store button down here And I'm going to store that answer into the letter A, and the letter A sits above the math key. It's green, so I'm going to hit alpha, math, enter. That means that this unrounded number is now in the letter A. So when I go to plug that A value into this equation, it'll look like this. Let me clear that. 4 times alpha A raised to the third minus 39 times alpha A squared plus 93.5 times alpha A. So my volume now, rounded to thousandths, the maximum volume is 66.148 inches cubed. So that's what's going to fill in this blank right here. 66.148 inches cubed, or cubic inches. So this would be my final answer. And what you want to do is when you make your final statement, make sure you've answered all the questions that were asked. So if I look back here, what did they ask me? How large should the squares be cut to ensure the box holds as much as possible? I did that. That's my 1.585 inches. And then what is the resulting max volume? And that's my 66.148. So I would say that is a clear-cut answer, answering all the questions in this problem. Okay, so there you have it. Tune into the next video, which will be the third video on optimization, to tackle the back of this worksheet, example 2.